are tackling CO12 today, which is simplifying an exponent or an expression with a zero power. Okay, zero power. And this one's really easy to figure out when you're using the rule because the exponent is literally a zero. If you look down further on the page, you'll see a whole bunch of zero powers. So we have CO10, which is multiplying by the same base. You recognize that because there's a multiplication symbol. We have CO11, which is dividing by the same base. You recognize that because it's a fraction, which is a division. And now we have CO12, which is a zero power. And you can recognize this because, like I said, the exponent is literally zero. Okay? And we're going to jump straight to the rule and then explain it using mathy things. Okay? So an example of something to the zero power would be like 12x to the zero. Okay, 12x to the 0. In this case, the coefficient stays the same. This is the only rule in which the base changes. Okay? This is deceivingly easy because when we get to what the rule is in a nutshell, a lot of kids just kind of latch onto that. Whenever they see a zero power, they do the exact same thing. They forget that sometimes the coefficient can adjust things. But this is the only rule where the coefficient stays the same and the base changes. The base becomes a 1. Okay? The base becomes a 1. So what this expression really is saying here, this x to the 0 is the same as 1. And so this is really saying 12 times 1, which is 12. That's why the coefficient stays the same, because you're multiplying it by 1. Okay? Anything to the 0 power equals 1. So the rule, in a nutshell, is any base, and I'm underlining base because the coefficient's not affected, any base to the 0 power is 1. Okay? And we are going to look at this using a couple different things. Okay, two different angles, things we've already talked about before here. Right? We know that anything divided by itself equals 1. You've learned that before. Right? So if I had something like n to the 8th over n to the 8th, I know this is going to equal 1. Because it's something divided by itself. Right? Anything divided by itself equals 1. That's a property of division. When we divide by the same base, if I take the same expression, and I take n to the 8th over n to the 8th, think about CO11 here, which is where this comes from. What do I do with the powers? Subtract them, right? So what would n to the 8th over n to the 8th equal if we're using CO11? N to the 0. Because the base stays the same in CO11, what we just corrected, right? The base stays the same. The exponents are subtracted, and 8 minus 8 equals 0. Okay? Now, next year in geometry, you're going to learn something called the transitive property. The transitive property basically says that if A equals B and if A equals C, what do we know about B and C? They're the same, right? If A is B and A is also C, then B has to be the same as C. That's what we've got going on here, right? Essentially what we've just proven is that if n to the 8th over n to the 8th equals 1, as we said here, and if n to the 8th over n to the 8th equals n to the 0, as we said here, then n to the 0 must equal 1, right? Does everyone follow that logic?
Yeah.
Okay? And since n is a variable, that means we can plug in anything for it. So any base to the 0 power has to equal 1. Okay? And like I said, this is deceivingly easy here because, again, when people see 0 power, they just put a 1 down. 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay? But you've got to look at what else the expression has. So we're going to capture this, save it, add it to my library of teaching, and here we go. N to the 0 is the same as 1. We just covered that. That's your final answer. Okay, you are done. X to the 0 times y to the 0.
1.
What is that really saying?
1 times
1 times 1, right? X to the 0 is a 1. Y to the 0 is a 1. We're multiplying those.
1.
And 1 times 1 equals 1. Okay?
I'm so good at math. Oh my god. I need 280 on my
3,481 to the 0 power is...
1.
Wait, I thought coefficients didn't change.
It's not a coefficient.
It's not a coefficient,
It's a
right?
base.
It is a base. The exponent is attached to it. So even a number to the 0 power, if it's the base, it equals 1.
Oh my god.
Okay? Ah, there's the trap. Is everything just 1? Peyton, that was perfectly timed because the next one is not. What is the next one?
7.
7. This y to the 0 equals 1, but the coefficient not being affected by the power, this is really saying 7 times 1, which equals 7.
This is 1 still.
Okay?
1.
How about the next one? Who's got that one for us? Christian.
-9.
-9. The n to the 0 equals 1. Owen, Grace? -9 times 1 equals -9. And that is your final answer. Okay? What about the next one? What does the y to the 0 equal? 1. And so if we've got x cubed times 1 times z squared, does that times 1 even really need to be there?
No.
No. When you've got something to the 0 power in the middle of an expression like that, you can really just kind of pretend it isn't there. Because multiplying x cubed by 1 times z squared is going to be x cubed z squared anyway. Right? There's no 1 in your final answer, but the fact that y to the 0 equals 1 means you're multiplying by 1, the value doesn't change. Okay? This is one that trips up a lot of folks. What do you suppose that's going to be? Raise your hand for this one. Think about it. Negative t to the 0, what that's going to be. Olivia?
-1.
Well done. T to the 0 equals 1. This negative sign is not part of the base, it's not in parentheses, and so -1 is going to be your answer. What other one on this page is the same situation here? Addie?
Oh, the -8.
Yes, the a to the 0 equals 1, but this negative sign not being part of the base, -1 is going to be your answer. So, CO12, it's a one-pager, your homework for tomorrow. Let's do the number game again. That was fun. Maybe tomorrow you'll win. And you've got about 5 minutes to work on it now. Lauren. Hey, whoa! Lauren's got the floor. There's only one Lauren in the room, so one voice I should hear.
Will you go to the one to the left of the -80?
Yeah.
Will you do that one?
Yeah, so this one has got some other rules kind of involved in it. X to the 5th times x to the 9th times y to the 5th. We have to simplify that first. You see the multiplication symbols, so you know which rule we're using here, right? We're multiplying by the same base. What is that numerator going to simplify to be? How many x's are up there total, Lauren?
2.
Well, there are 2 x terms, but if one's x to the 5th, one's x to the 9th, how many are there total? There are 14. So our numerator becomes x to the 14th, y to the 5th. Our denominator, we can't combine those x and y bases, so we just write x to the 14th, y cubed. Where do you go from here? Matthew? Oh. Where do you go from here, Pete?
1.
As your final answer? No. What does equal 1, though? The x to the 14th over x to the 14th, right? Anything divided by itself equals 1. It can be canceled out. The reason why the whole thing doesn't equal 1, Peyton, is because we don't have the same number of y's up top as we do on the bottom. How many more y's do we have up top? 2. So our final answer is going to be y squared, because 5 minus 2 equals, or 5 minus 3 equals 2.
That makes sense.
Okay?
It's not as simple as I thought.
Okay. Anything else?
The
Yes.
1 over n to the 0, can't divide by. Oh, that's 1.
Yeah.
Oh, yeah. That's 0.
Lauren.
Would the n4 times n0 times n7 be n11?
Yes, it would. 4 plus 0 plus 7. All right, folks. Homework for tomorrow. That's it, math.